Welcome students. In this class we continue the chapter real numbers, chapter 8, exercise 8.1. Today in this class we continue the third problem. Previous class we completed the first two problems. Here we start solving the third problem. Before that we have this one, that is a is equal to b cube plus r, where 0 less than equal to r less than b. So a is called dividend. We studied all this in the previous problem. Once again I am repeating. And b is called the divisor. So a is dividend, b is divisor, and r is remainder. R is the remainder. So what is the formula we can write as? So we'll substitute, that is dividend first is equal to divisor into quotient plus that remainder. This is the form, that is dividend is equal to, this is dividend, this one is divisor, this one remainder, where 0 greater than equal to r, so 0 less than equal to r less than b. Dividend is this, then we can write in this general form, dividend is equal to divisor into quotient plus remainder. So we'll see here 3, 7, then 3 2s are 6, 1 is the remainder. So what is the dividend? 7 is dividend and 3 is the divisor and the quotient is 2 and the remainder is 1. You remember this, then the problem will be easy. 7 is the dividend and divisor is 3 and quotient is 2, remainder is 1. So this is just an information or important note for you all. Next we'll start the problem. What is the problem here? So an army contingent of 616 members is to march behind an army band, so of 32 members in a parade. Two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So there are two groups of army contingent. One contains 616 members and other contains a band group of 32 members. So these two groups have to march in the same column. So in the question they have asked what is the maximum number of columns in which they can march. So we'll find out. So here 6-1, we'll see what are the data given. First we'll write army contingent members. That is the first group members is equal to 616. Next data given is army band members. That is the band group. This is the one group, this is the another group, contains 32 members. So now we take 616 as the dividend is equal to, next 32 as the divisor. First group is the dividend, second group is the divisor, into, we'll just see the first working, then we'll continue. Here I will just take, that is 32, then 616. So 32 in 19s, this comes as 608. Then the remainder will be 8. So 8 is the remainder. So we'll write now this 616 is the dividend, 32 is the divisor, then the 19 is quotient plus the remainder is 8. Write in the general form. Since the remainder is not 0, that is 8 not equal to 0, again we have to continue this. So until we get remainder 0, this has to be continued. Since 8 is not equal to 0, again we have to continue. Again 32 will come in the place of dividend. So 32 will be the, 32 will be here. 32 will be the dividend and 8 will be the divisor. 32, then 8 will be the divisor. 8 4s are 32. Remainder is 0. So into quotient will be 4, then plus 0 is the remainder. So this is the solution for the above problem. So hence, finally we have to write hence maximum number of columns is 8, in which they can march, in which the two groups can march, which they can march. So this is the solution for the first problem. So we'll continue the second one. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer y. So for this, first step is take y as dividend. So take y as dividend, and 3 as divisor. Therefore we can write in the y is equal to y is dividend and 3 as the divisor, then 3q plus r, where 0 is less than equal to r, less than equal to 3. This is by Euclid's division lemma. So next is, when we have taken this one as 3, so write in the next step, take is equal to r is equal to 0 1 2. After taking this, if next step, if r is equal to 0, then substitute r here, then y is equal to 3q. Next step, if r is equal to 1, then y is equal to 3q plus 1. If r is equal to 2, then y is equal to, substitute here, 3q plus 2. Thus, square of any positive integer is either of the form 3m or 3m plus. Thus, the positive integer y is of the form, that is 3q plus 1 or 3q plus 2. So this is the solution for the fourth problem. So we move on to the fifth one. So now we have to move on to this one, that is the fifth problem. So we'll continue this one. That is one more thing. This was the problem. Then we'll continue with this one. That is fourth one. Consider. So fourth problem. Consider continuing this, consider y is equal to 3q on squaring on both sides. Therefore y square is equal to 3q square is equal to y square is equal to 9q square is equal to 3 into 3q square. Now put this one, that is, or take, you can write 3q square is equal to m, where m is some integer. So this is the actual solution of this fourth problem. So they have given us, that is, see the question, that is the square of the positive integer. I'll just read out the question. That is, Euclid's algorithm show that the square of any positive integer is of the form, that is 3m or 3m plus 1 for some integer m. So we'll continue this one. So we'll take y is 3q square on both the sides and we'll get this one. Then we'll take 3 outside and 3 into 3q square is remaining, which is equal to m. So substitute m on this one. So we'll get what? 3m. This is the equation 1. Next step. Consider y is equal to 3q plus 3q plus 1 squaring on both sides. Squaring on both sides, that is y square is equal to 3q plus 1. Now apply a square plus b, a plus b the whole square. So 9q square plus 6q plus 1 square is equal to 3 common outside, 3q square plus 2q plus 1. Now again substituting this one, that is m, or put, you can take, or take 3q square plus 2q is equal to m. Same thing we have to write, where m is some integer. After this, next step is substitute m here or here, 3m plus 1 we get. So this will be the second equation. Next step is consider, that is y is equal to 3q plus 2 squaring on both sides. Squaring on both sides. Y square is equal to 3q plus 2 the whole square. Therefore y square is equal to, again, a plus b whole square. Apply here. 9q square plus 12q plus 4. Therefore y square is equal to, take 3 common, that is 3q square plus 4q plus 1, then plus 1 outside. So this one we have to split, that is for 3 plus 1, this will become, so here 3 common, this is done like this. 4 is equal to 3 plus 1, 3 comes inside the bracket, then this remains as 1. Therefore take that is 3q square plus 4q plus 1 is equal to m, where we can write as where m is some integer. Therefore what happens, we have to substitute here, that is 3 into m plus 1. So this is the third equation. So where m is some integer. Finally, thus we can write, this is the solution, proper solution of the fourth problem. Thus the square of any positive integer can be either of the form 3m or 3m plus 1 for some integer m. So this is the solution for the problem, fourth one. So we'll move on to the fifth problem. So here also same thing, we have to cube. So this is, use Euclid's division lemma to show that cube of any positive integer is of the form 9m plus 1 or 9m plus 8. So I'll directly start the problem. That is, consider a positive integer y, then y is of the form 3q plus 1 or 3q plus 2, where q is some integer. Next is consider y is equal to 3q and taking cube on both sides. So this one y cube is equal to 3 cube the whole cube. So what we get is cube this 27 cube, then we can write as 9 into, split this and write as 9 into 3 cube is equal to 9m. So wow, 9m means take 3 cube is equal to m, where m is some integer. M is some integer. So after this, next step is consider y is equal to 3q plus 1 and taking cube on both sides. Therefore y cube is equal to 3 cube plus 1 the cube. Expand this, that is a plus b whole cube, that is 27q plus 27q square plus 9q plus 1. So this is of the form a plus b cube. I'll write the expansion, that is a cube plus 3a square b plus 3ab square plus b cube. Now y cube is equal to 9, take 9 as common, then 3q cube plus 3q square plus q, then outside bracket 1. So replace this all equal to m. So take m is equal to, I'll just write like this, where m is some integer. You can understand because previous problem is also same thing. So next, so y cube is equal to 9m plus 1. Similarly next one also same thing, repeat this, then y is equal to 3 cube plus 2, same thing, cube on both sides, that is y cube 3 plus 2 the whole cube, which is equal to, next step is, that is y cube, this is also a plus b whole cube form, 27 cube plus 54 q square plus 36 cube plus 8. So after this take 9 outside, 3 q plus 6q square plus 4q, then plus 8 outside. So what are we are getting, and this is, I'll write this one as equation 1 and this one as equation 2. So finally last one, as we are getting 9 outside, so we can write all thing represented by m. So 9m plus 8 we are getting, this is 3. Repeat all the procedure, but I have wrote in the short form because the previous problem is also same problem, the same procedure, but that is square, here it is cube, but write down every steps, but I have skipped some step, but it will be, that is understood. So next one is 9m plus 8. So now this is the end of the problem. So we got, that is from, we compare from equation 1, 2, 3, you can write the last one statement considering the equation 1, 2, 3. So we found out that the cube of any positive integer is of the form, I'll write down here only, from equation 1, 2 and 3 cube of any positive integer is of the form. So write down the form, that is 9m plus 1 or 9m plus 8. So this is the solution for this whole exercise 8.1. So if you have any doubt, comment me, subscribe my channel, share and like all the videos. Thank you.